Bruno's Appliance here again, and today we're going to go over some microwave diagnosis. We're going to test a magnetron, a couple capacitors, and the dreaded diode at the same time. If you like what you're seeing, go ahead, like, subscribe, it helps. And then follow us on Facebook and like our page there as well. So now let's dive into what we are talking about, because I want to try to make this a short video. Again, we're going over microwaves. First thing that we're going to look at, if the microwave is not heating, a couple different things that you're going to want to test. If you have no power, nothing's lighting up, there are a couple of things that we need to look at. One would be this guy. Let's see. No cameraman again today. Right here is your fuse. Now you're going to want to test for continuity on your meter, so it should get a buzzing sound between it. Sounds good to me. The other thing is, and this is a small microwave, so they're not all made exactly the same, but they do have the same components. So you will have a fuse on your noise filter board that cuts all power off. But let's say your fuse is good, then you have a thermal cutoff that passes power through it as well. So that just reads the temperature of the cabinet, and it'll open up if it gets too hot, and then therefore cuts all power off to the whole unit. Next couple of things we're going to go over is going to be a magnetron. So this is actually your power source. This is what heats your food up in the microwave. A lot of them have a TCO on them as well, and we're going to test those out real quick. Again, we're still using the meter set to continuity. So continuity, it's going to read, if you have a nanometer, a multimeter should run continuity and nanos, and all on the same setting. So that's good. It means it's closed. We want a closed circuit so it completes the circuit. Right? That's what we're looking for. If it was open, we would have no sound coming out of it, and it would be an open circuit, and it'd be bad. And then why would it be bad? Well, because the magnetron got too hot for some reason. So with the magnetron, same deal. It's good. We get continuity. They might show a number and then drop off and have continuity through it, so it's a good magnetron. And this one here on this unit is the same thing. It's good. It starts at a certain number and then drops out immediately. So those are good. So very quick and simple on that. Now, if we have power, but it makes a loud noise when we start it, and it scares the crap out of you, like a kind of noise sound, it's either the diode or the cap. Typically it's the diode. And that's this little guy. This little guy is actually connected to this guy, which is a capacitor. So we're going to test these out real quick. Again, diodes, they only flow power one way, and you have to test with a 9-volt battery, multimeter set to voltage, set to DC voltage. And the easiest way to do this is just to see how it turns out. So you put meter hooked up to one side, and then now this is going to be the end of your lead, and we'll take that to the positive, and then we'll take our other meter here, other lead, and we'll go to the battery, and that gives us a negative 0.5, and that's just because the leads are backwards. So if we flip the battery around to where my red lead is actually on the positive side and my black is on the negative of the battery, I get point. So I get nothing this way, in the correct way, because the power is feeding the wrong way on the diode. So if we actually take the diode, flip it around, and do that to where the diode is on the negative side and that goes to the positive side, I get 5 DC voltage. Learn something new every day. So we know the diode's good, our battery is good. That would be one thing too. You want to test your battery before you go to test your diode, because if you don't have a good battery, you're not going to get any reading out of it. Next up, I have a couple different things. We're going to go over 3 of these. A couple different tools on this one. I have a multimeter that reads for nanofarads for testing capacitors. And when we look at a capacitor, what we're actually going to be testing. One, this is your setting here for reading a capacitor. Now, on your capacitor, this is what you're looking for. Where are we at? Can we zoom in on that? I only had a cameraman. She's busy doing school. Either way, it's a 0.8 UF, give or take 3%. So, what we're going to do is we're going to take one side, one lead to one connector and to the other one, and see what our meter reads. And our meter is reading 0.8, so that is dead on. Next, I have a different type. This guy is so nice. You can actually see what goes on with this one. So we connect these 2 little magnet leads to this. Look at that, 0.78. So that's within our limit of give or take 3%. That is awesome on that. This guy works tremendously. So we know that is a good diode. So we got some couple of bigger ones. They're both the same. So it's 1.05 on the reading, give or take 3%, meaning this should be at the lowest a 1.1, or on the opposite side a 1.8, something like that. Okay, so with this lead we test and we get a 1.1 on the reading. Take this guy here. This guy works tremendously well. Definitely makes it a lot easier. Just stick those guys in there real good. And if it's good, 0.1. So with the 2 different ones, this capacitor is on the very low end of just being out of range, so probably need to toss it out. I think my other capacitor is the same, so we're going to do the same. Again, this is a 1.05 on the reading for it, so we connect our leads up to it, and what do we get there? 1.1. So right on the low end. It would probably works, probably okay. So, but let's see what we get with the multimeter. .1 on the multimeter as well. And I'm real big into double checking, having 2 different meters. I actually have a different multimeter as well, but it doesn't test everything that I would like it to, and the range is different on the ohms and everything. So that is a quick overview of a microwave. This was working before I took it apart, and now I'm going to go over. So, fuse, noise filter board, whatever you may want to call it. Check your fuse if you have no power. Next, find the cabinet TCO. This is just a very countertopped one. We use it here in the office. Thermal cutoff for the cabinet, and being the fact that it's right next to the magnetron, and this magnetron does not have one on it. So this is your cabinet. This will cut off all power as well, because it runs back up to here, comes right back out of the noise filter board. Right, so that's your circuit. If that's bad, replace it. You should be good to go. Fuse is bad, replace it. Should be good to go, unless you have a bad magnetron, capacitor, or diode. So that is it for today. You guys have a good day. Again, microwave, quick diagnosis on why it's not heating. This guy here, just in case you're wondering, that's a transformer that I've never seen one go bad. So, but hey, there's always a first time. All right, so you guys have a good day. God bless.